Hi there, folks. Today we're looking at the quadratic formula. This is the next method for solving quadratics that we're going to do. And it's really the kind of catch-all method. You could use the quadratic formula every time. I certainly wouldn't recommend that. I would always check factoring and then move on to the quadratic formula if factoring doesn't work. Okay, and we'll see an example that could be solved by factoring that we'll solve using the quadratic formula, just to compare the two in terms of the amount of work that you have to do. Completing the square is a really nice method for when A is 1 and B is even, but the quadratic formula kind of picks up where that leaves off. And really, the quadratic formula is just a rewrite of the equation ax squared plus bx plus c after we complete the square. So let me show you where the quadratic formula comes from. If I generically have ax squared plus bx plus c equals 0, and I were to solve by completing the square, the result will be the quadratic formula. So let me show you this real quickly. And I'm not going to expect you to derive this thing, but I want you to see where this comes from. Someone took this equation and said, hey, let me solve for x using completing the square. So they said, let me create space by moving the c value. So we created some space. And then we said, okay, I can't complete the square unless the a value is a 1. And right now the a value is an a. So we have to divide each side by a. And so what that gives us here, we get x squared plus b over a. X with a little bit of blank space, and then the negative c over a. And now what we have to do is we have to take x's coefficient, used to be called the b value, right, divided by 2 and square it, but it's that entire thing, that b over a. So let me take those off to the side. I have to do b over a. See, that's my new b value. That's the thing in front of the x. I have to divide that by 2, and I have to square it, all right? And this is where students get a little bit of loss deriving this thing, but really, it's 2 over 1. Dividing by a fraction, same as multiplying by the reciprocal. Let me kind of break this down. That's times 1 over 2. So that's b over 2a squared is a b squared over 4a squared if I square each of those pieces, okay? So that's what goes in my blank here, so plus b squared over 4a squared. Whatever I do to one side, I have to do to the other side, so I have to add that over here as well. And so I have to use my shortcut for factoring this thing. If I factor this guy, this is just going to factor into x plus b over 2a, or sorry, b squared over, b over 2a squared. And again, I'm just stealing that right from inside these parentheses, all right? That's how the shortcut for solving by completing the square works. On the other side, however, I have to add these things together, so I need common denominators. So let me take that off to the side. And since one of the denominators is a 4a squared and the other one's just an a, I got to turn that a into a 4a squared, so I'm going to multiply it by 4a over 4a. Ready? I'm just getting common denominators, and so that gives me this. It gives me negative 4ac over 4a squared plus b squared over 4a squared. And if I combine those into one fraction, I'm going to rewrite it as b squared minus 4ac over 4a squared. Okay? So I'm just kind of combining those two fractions, and it gives me this. Now I can solve using the square root, so I take the square root of each side. Again, I have to remember when I do the square root here, I have to remember to do the plus or minus. I also have to remember that I just take the square root of each of these pieces individually. So plus or minus the square root, that's b squared minus 4ac on the top. Underneath, 4a squared, if I take the square root of that, the square root of 4 is a 2. The square root of a squared is an a. Remember, I divide the exponents. And now I'm going to go ahead and solve for x. I'm going to subtract that b over 2a from each side. And if I were to leave that as two separate fractions here, if I leave it like this, technically that works, and I could leave it like this, and I could plug values into this to solve for x. But since they already have common denominators, I can combine this into one fraction. When I combine it into one fraction, it looks like this. the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, that's the quadratic formula. And if you remember the quadratic formula, if you've heard it before, if you've committed to the memory before, you'll know that this is the quadratic formula. But this is where the quadratic formula comes from. It's really just somebody said, hey, let's complete the square one more time and then never have to do it again. So they took that generic ax squared plus bx plus c equals 0, and they said, let's solve this literal equation for x by completing the square, and this is what they came up with. Okay? So the quadratic formula here, again, is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And really, the nice thing about the quadratic formula, what it does for us here, is it just allows us to take the values from the equation, the a value, the b value, and the c value. Remember, ax squared plus bx plus c. A is just the number in front of x squared. B is just the number in front of x. C is just the number by itself. And so I can take those three values and just plug them into this formula, and I can get the answer by simplifying. All right. For example, if I look at this first guy, and keep in mind, when I see this this symbol right here, I call that the opposite of b. Some teachers and some students will say negative b, but really that symbol is an opposite symbol. We call it a negative when it's in front of a number because, well, that's what the opposite of a number is. It's a negative number, okay? But we don't know if this b value is going to be positive or negative yet, all right? We simply say it's going to be the opposite of b. So when I look at this first example, the b value here is a negative 4, which means the opposite of b is a positive 4 for my equation. And then plus or minus the square root. And then b is a negative 4 squared minus 4 times a, which is a 1, times c, which is a negative 2. And the signs here become really important. You have to make sure you keep the sign with that value. All over 2 times a, which is also a 1. And again, I'm just reading those off of this equation. There's the 1, the 4, and the negative 2. It's a, b, and c written out for me when it's in this format. Okay? So I just plug those in, and now it's just time to simplify. So x equals this thing. And now I simplify this until I have a simplified version of this thing. I just start plugging away. So inside here, I always do this in the same couple steps. I always square this guy. That's a 16. And then in the same step, I multiply out the 4, the 1, and the negative 2. And just be really careful with the signs here. You can think of that 4 as a negative 4 and just say negative 4 times 1 times negative 2 is a positive 8 and write a plus 8 down here. Or you could just say 4 times 1 times negative 2 is a negative 8, but then keep in mind it's minus a negative 8, which is adding the opposite, so it's a plus 8. And then that's all over 2. And now the next step, I simplify what's under the square root by adding it together. That's a 24. Now I simplify the square root the same way I always simplify the square root. 24, that's 4 times 6. The square root of 4 is a 2. The 6 is still trapped. And again, take that off to the side if you need to, all right? Hopefully you're getting close to being able to do that in your head, but if you're not, take it off to the side. And now the last thing I can do here, because everything's divisible by 2, all those outside numbers, I can use my distributive property. That's a 2 plus or minus 1 root 6 by just dividing each of those. 4 divided by 2 is the 2, and then 2 root 6 divided by 2 is just the root 6. Those are my two answers. And once again, they're answers that I would not have been able to get to by something like factoring, all right? However, this is an answer I could get to by completing the square. Completing the square wouldn't have been too bad for this one. And so you kind of have to make a judgment call in terms of, well, would completing the square have been easier for me for this one? All right, do I understand it well enough that I can use it when the a value is 1 and the b value is even? The fact of the matter is completing the square requires a lot less simplification, especially in terms of the square root. Okay, I think completing the square is easier for this example when the a value is 1 and the b value is even, but you might disagree, and that's okay, all right? You could use the quadratic formula, but you have to make sure you simplify it all the way to the end, okay? Simplify it as much as possible, all right? If I look at the next one, see the next one, I cannot use the quadratic formula the way this is written. It's not in that format, ax squared plus bx plus c. The c value is on the wrong side. Okay, and so what I have to do is I have to get this thing, just like in factoring, I have to get the thing set equal to 0 first, okay? So subtract that guy, that's an x squared minus 2x minus 5 equals 0, okay? Now I have it in that format, I can see a, b, and c, Remember, my a value is right here, so a is a 1, b is a -2, c is a -5. So here we go, opposite of b. The b value is a -2, so the opposite of that is a +2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And now again, I continue to simplify. I always use the same couple steps. So I always start in here and say, okay, that's a 4. And now when I multiply those guys out, that gives me a +20. Now I add those guys together under the square root. That's a 24. And no, it's not going to be 24 each time. I just happened to pick another example that had a 24 there. So I continue to simplify. 2 root 6 over 2. And now once again, I can divide each of these by 2 using my distributive property. 2 divided by 2 is a 1. 2 root 6 divided by 2 is a root 6. Okay, so it's 1 plus or minus the square root of 6, and that's it. All right, it's all about simplification. And students will sometimes abandon completing the square here in favor of this, and that's okay, all right? That consistency can be really important for you. If you've decided, completing the square is a little bit tough for me, well, then don't do completing the square, okay? The fact of the matter is, you can always do the quadratic formula, okay? I wouldn't recommend abandoning factoring because it's such an easy method and it saves you so much time and work, okay? But if you prefer this over completing the square, you may use it instead of completing the square. If you were really good at completing the square, you should still use completing the square for these particular two examples when the a value is 1 and the b value is even, okay? It's a little bit faster, a little bit easier in terms of the amount of simplifying you have to do, okay? If I look at something like this guy, this is one that the best method by far is going to be the quadratic formula. Completing the square is not great because the b value is odd and I end up with these fractions. I can't factor the thing because if you build a bridge, two numbers that multiply to 8 but add to a 3, not going to happen, all right? This is the kind of example we want to use the quadratic formula for, okay? And so here's what I'm going to do. I'm going to go ahead and set this up. Opposite of b, so my b value this time is a 3, so the opposite of that is a -3, plus or minus the square root of 3 squared minus 4 times a, which is a 1, times c, which is an 8. All over 2 times a, which is a 1. And now I continue to simplify. Here we go. -3 plus or minus the square root, that's going to be a 9, minus 32. I don't like how big that square root was. Okay, so 9 minus 32, all over a 2. I continue to simplify when I subtract these guys. That's a negative 23. I continue to simplify. I can take an I out of that thing. So that's going to be x equals -3 plus or minus I root 23. I wrote a 33 like a crazy person. Let me try again. And now from here, I mean, there's not really anything else I can do or need to do. I can leave it like that. I'm not going to use my distributive property like it did in the other one. If you want to leave it like this, that's fine. If you want to rewrite it as -3 over 2 plus or minus I root 23 over 2 and do your distributive property, that would also be acceptable, okay? And the only reason I might recommend that is students have a lot of trouble simplifying from this step to this step in these previous examples, okay? And from this step to this step, we forget to do that. But if you always split it up like I did here, then making sure to reduce those when you need to becomes a lot easier, okay? If I look at the next one, same kind of thing here. Once again, this is not written properly. If I think about it, I have to subtract that 6x from each side. Okay, I got to have this thing set equal to 0. And then the other thing here, make sure you write this in the appropriate order. It should be 3x squared minus the 6x plus 2 equals 0. Okay, make sure you write that in the appropriate order. It should be the x squared, then the x, then the constant term. That's in the right format for identifying a, b, and c. And now, opposite of b, so b is a -6 here. So the opposite of b is a +6, plus or minus the square root, b squared minus 4 times a times c, all over 2a And now I continue to simplify. Again, here's my couple steps that I always do. And notice, consistency makes these a lot easier. I square this guy 36. I do the multiplication here. That gives me a negative 24 over 6. And now let's subtract what's inside there. That's going to give me a 6 plus or minus the square root of 12. That's 4 times 3. The square root of 4 is a 2. The 3 is still trapped all over 6. And now I can reduce. They're all divisible by 2. So this becomes 3 plus or minus root 3 over 3. Okay, that would be an acceptable answer. Or if you completely split it up, you would do 6 divided by 6 and get a 1. And then you would do the 2 over the 6 and get a 1/3. All right, so if you wrote your answer like this, if you did this, 1 plus or minus root 3 over 3, that would also be an acceptable answer. And that's what you would get if you literally split these up into 6 over 6 and then the 2 root 3 over 6. Okay, and again, that is a great way to do this, all right, if you're worried about forgetting to reduce this thing all the way. Okay, if I look at the next one, again, same kind of thing here. I need a 0 over here first, so subtract that 6 from each side. And now I plug it into my quadratic formula. X equals the opposite of b is a positive 5 plus or minus the square root of b squared minus 4ac. Again, be careful with the signs, all over 2a. The thing that students tend to mess up here is signs. They make sign errors when they're doing this. And it all comes down to being careful and being consistent. So here's my careful consistency, 25. Be careful with those negatives. I see right away it's going to be a positive, going to be plus when I multiply it all out. All right? And then that gives me a 48. I continue to simplify. And look at that. There's not anything else I can do here. There's no perfect squares divided evenly into 73. This one is done. Okay? And see, that's the nice thing about using the most effective method is when you use the most effective method, you'll have to simplify less. Okay? That's essentially what it comes down to. If I use the quadratic formula for one that I could use completing the square, I have to do more simplification than I would if I had done completing the square. But this is one that there is no other method that would be better than the quadratic formula. And notice the amount of simplifying is limited. Okay? If I look at the next one, this one is all out of sorts. It's not in the right format at all. Let's multiply this. Let's distribute this guy. I have to have it in that kind of x squared, x value, constant term format. So x squared plus 7x equals 1. Now let's subtract that 1 from each side. Okay? Put it in the right format so that we can read A, B, and C. And now we can plug it into our quadratic formula. Opposite of b is a negative 7 plus or minus the square root 7 squared minus 4ac. Again, be careful with the signs, all over 2a. And now I simplify. 49, that's going to be a plus 4. It looks like I get negative 7 plus or minus the square root of 53 all over 2. And there is nothing else I can do about that one. That's my answer. All right. And once again, if you were to split that up, if you do the negative 7 over 2, and then the plus or minus, and then the square root of 53 over 2, that's fine as well. That's kind of the format we would get if we had solved by completing the square. Okay? And so again, the quadratic formula is just a formula derived from completing the square. Somebody said, hey, let's rearrange this. Let's solve it for x in the generic format so that I can just take the coefficients a, b, and c, plug them in, simplify, and get my value, get my simplified version of the answer for x. Okay? And the last thing I'll leave you with here is, once again, if we were doing a word problem here, if I asked for a decimal approximation, you have to punch two things in your calculator. Using this last one as an example, if I ask for a decimal approximation here, you would do -7 plus the square root of 53 divided by 2 and figure out what that is on your calculator. And then separately, because there's two answers when you have a plus or minus, you would have to do -7 minus the square root of 53 divided by 2 and then plug that into your calculator. So keep that in mind. I will ask you for decimal approximations on certain examples, so understand that this is two things when you plug it into your calculator, okay? All right, in these next couple, just doing a couple word problems to kind of see where we might run across solving quadratics in maybe a real-world type of situation. If we look at this first one, it says a rectangular table has a length that is 10 inches more than twice the width. The area of the table is 72 inches squared, or square inches. Find the length and width of the table. And so the first thing that I might do with something like this, guys, maybe I would just draw a quick picture, just so I can understand the situation. So if I look at something like this, guys, so here's my rectangular table. It says the length is 10 inches more than twice the width. So I don't know the width, so I'm going to call the width W because that feels like a good variable. So then the length would be 2W plus 10. All right, it's 10 inches more than twice the width. And so if I wanted to find the area of this thing, area of a rectangle is just length times width. And so this would be W times 2W plus 10. And so if I had something like this, W times 2W plus 10, that's the area of the rectangle. We want that to equal the 72, all right? And so I want to solve this thing. The only way to solve this thing, I kind of take the approach that I normally would when I'm solving an equation. I simplify and then solve. So I would simplify by doing my distributive property. So that's a 2W squared plus 10W. And remember, this is a quadratic. And with a quadratic, we kind of have to go through our progression of how do we solve these different quadratics. Remember, we can solve by factoring, completing the square, or the quadratic formula. It really just depends on the situation. And so the first thing I would always do here is get it set equal to 0 and try factoring. We always want to try factoring first. And as we do this, you might notice here that all of these are divisible by 2, all right? And so I don't even want to build a bridge yet because they're all divisible by 2. Normally when we're factoring, we would just factor out the 2, but since we're solving, we just divide each side by 2 to get rid of that 2 first. So let's divide this thing. And now try building a bridge. See what happens. I build a bridge that's a -36. Two numbers that multiply to a -36 but add to a +5, well, that's going to be a +9 and a -4, okay? And so that means this thing can be factored, and I can factor it using my shortcut here. There's a 1 out front, so this factors directly into W plus 9 and a W minus 4. And now I set each of these equal to 0. And I solve each. And so I get two answers here. I get W equals -9, and I also get W equals +4. And I'll tell you right now, one of those answers doesn't make any sense. If we're talking about the width of the rectangle, the negative doesn't make any sense in this scenario, so we can go ahead and cross that out. The width is going to be 4 inches. So the width is 4 inches. Which then means the length, well, I just have to plug this back in. So if this guy is a 4, up here I would plug the 4 in. So that looks like an 18 when I simplify that. So that's 18 inches. Okay? So this is a smaller table, probably like a little end table or something like that. And, you know, again, we're just solving the quadratic. Could I have solved this using another method? Well, yeah, I could have solved using something like completing the square. But that would have been a great option because the A value wasn't a 1 originally, but after it was a 1, the B value is not even. The quadratic formula would work fine for this one, but again, always check factoring first, okay? If I look at the next one, it says a model rocket is fired into the air and follows the equation H equals -4.9 t squared plus 50 t plus 0.5, where t is the time in seconds and h is the height in meters. How long will it take the rocket to hit the ground? And so here's the thing. It's asking me how long. It's asking me to solve for t, and it's asking me to solve for t when the height is 0. So you hit the ground, Well, it'll hit the ground when h is 0, and so that's the hint that it's giving us here. All right, h equals 0. It hits the ground at a height of 0, so really, here's the equation I want to solve. I've got negative 4.9 t squared plus 50t plus 0.5 equals 0. Okay, I want a height of 0, so if I put a 0 in here for height, this is the equation I get. And even though there's decimals involved here and it kind of looks a little bit ugly, this is still just a quadratic in the format ax squared plus bx plus c. Yeah, it's t's instead of x's, all right? And yeah, we've got some decimals thrown in here, but it's really the same thing. And if I wanted to, I could build a bridge here and see if this thing's going to factor. It's not very likely, all right? And as soon as I see the decimals, I'm thinking quadratic formula all the way. Okay, completing the square is not going to be great because of the decimals, because I don't have an a value that's 1. So I'm going to go to the quadratic formula. Instead of x equals, it's just going to be t equals because I have a different variable. All right, opposite of b is a negative 50 plus or minus the square root of b squared minus 4 times a, which is a negative 4.9, times c, which is a 0.5, all over 2a. And again, I just simplify this. I simplify this doing the same couple steps that I've always done. So I'm going to do the 50 squared first. And again, use your calculator for this. You know, students sometimes try to do too much in their heads. The next one, 4 times the 4.9 times the 0.5. Let's see, I've got a plus 9.8 when I multiply all that out. And again, be careful with your signs. I'm still simplifying these, even though it's a little bit ugly. Down here, I get a negative 9.8. Even though the decimals, make us a little uncomfortable, that's okay. We use our calculator. We follow the exact same steps that we've been following to simplify this thing. So here, let's see, negative 50. Whoops. That's a 0. And so I simplify it to this point, all right? And this is where I'm going to really need the calculator, okay? I have to remember that this means two things. And normally, when we're solving these, we would just leave it in this radical format. But for something like this, it doesn't make sense to leave it in terms of a square root. It doesn't make sense to leave our answer like this. It makes sense to plug this into the calculator, okay? And so make sure we plug two things in here. One of these is negative 50 plus the square root of 2509.8, and then divided by a negative 9.8. And then the second one we have to plug in is the negative 50 minus that thing. And so the plus or minus literally becomes two things. It gives me two completely separate things that I need to plug into my calculator. And let me pull my calculator up just so you can see me punch this in. But I would just do this. I'd say, hey, negative 50 plus the square root of 2509.8, and I hit enter, and now I'm going to divide that by a negative 9.8. And so that little e on the calculator, that'll come up sometimes. That's scientific notation. It's telling me negative 9.99 times 10 to the negative fourth. And scientific notation, remember, I'm going to move that decimal 4 places. Whoops. Let's see, that's 1, 2, 3, 4. Okay, so just reading our calculator a little bit gives me a negative 0.000999. And now with the second one, I do the same thing. So again, negative 50 plus minus this time the square root of 2509.8. I hit enter, and now I do divided by the negative 9.8. And it says, hey, 10.21. And so now I have to interpret each of these answers. Again, because this was a real-world type of scenario, one of these answers doesn't make sense. Remember, I was solving for t, which stood for time in seconds. And the question is, can time be negative? And the short answer there is no. Time can't be negative. So it's going to hit the ground at 10.21 seconds. Okay? So let's go back up here and answer the question. Again, there's not really much involved here that we haven't already done. It's just a matter of reading the question, understanding that we're solving a quadratic by the quadratic formula, and then it's a matter of just making sure we take our answer all the way down to a decimal approximation. Okay?